Another formula, if you'd like, that I would like us to look at here is determining monthly loan payments. And this looks it's complicated formula. I agree if you say that. If P dollars are borrowed at an annual interest rate R, which we know, expressed as a decimal, yes, we know that, the payment M made each month for a total of N months. So N is in month, not years in this formula. N is in month, not years. So I'm going to copy the formula. So this was my page 3. So M equals P. This is a formula that has no difficulty other than entering it in the graphing calculator. So that is the most difficult part. Not even that is difficult, but I just want to emphasize a few things. So remember, N is in months. Very important situation here. Something to remember. Okay, so let's take a look at an example. So Fermat's last bank makes a car loan of 18,000. So that's the P, the principal, at 4.6% annual interest, and a loan of a period of 3 years. Remember, N must be in months. How many months is 3 years? Anyone, please?
36.
Good. So we have 36 months. So I'm going to fill in the required, the given information so we can get the required M, the monthly payment. So we have 18,000. R is, they're giving us R as 4.6%, of course 0.046. So 0.046 divided by 12. And then we have 1 plus 0.046 divided by 12 raised to 36. And then in the denominator, the same thing, 1 plus 0.046 divided by 12 raised to the 36th power minus 1. I'm still recording because I will have one video for both situations. And then I'll stop the recording. Okay, because I'm recording on another device anyway. So what I would like you to understand here, let me stop sharing, sorry, so you can see, is the following. This has to have parentheses. This has to have parentheses. This has to have parentheses. I put brackets just for you to understand, to see what I added, right? So here it's in parentheses. This has to be in parentheses. And the denominator has to be in parentheses. The numerator has to be in parentheses. So careful how you enter all this. So I'm going to share my screen and let's do this together. So 18,000. Stop me if you have questions. Remember, this is not a monologue. The left parenthesis for the top, another left parenthesis, 0.046 divided by 12. Close. Open another one. 1 plus 0.46 divided by 12. Close the parenthesis. Power. You know me, I like the power to be in parentheses. Bring it down. Bring down the cursor and close. So this is just the numerator. Any questions on the numerator? Divided by, parentheses, another set of 1 plus 0.046 divided by 12. Close. Power, 36. Bring it down, minus 1. Bring down the cursor, -1, close. So everything I've done is a mistake because I didn't mean to put it in y equals. So I have to do it again. Sorry. We put it in y equals when we have to enter values, but I just went ahead and put in y equals. In this situation, this is not a function. We are not entering different values like I did before. So I have to enter it again. So sorry. But nothing is wrong. It's just that I'm not going to get an answer unless I take it out of there. And I don't know how to copy it and put it automatically in this regular screen. Sorry about that. My apologies. So 18,000. It's even easier to see in this case. Another set, 0.046 divided by 12, close, open, 1 plus 0.046 divided by 12, close, caret 36, bring down the cursor, close, divide, open, again, 1 plus 0.046 divided by 12, close, caret 36, close, bring it down, -1. For one value, we don't have to put it in y equals. We don't have a variable to enter different values for. Okay, so this is what he needs to pay for the next 36 months when I hit enter. This is the amount that he needs to pay, or they need to pay, for the following 3 years every month. Okay, so let's see how much this is. So this is the amount, the monthly payment to repay back the loan of 100,000 over 3 years at the interest rate of 4.6%. So M equals 536.25 per month. Let me say this from the very beginning and I'll stop sharing. Every time there is a measurement unit involved, the measurement unit has to be stated at all times, no matter what it is. Any questions on this monthly payment or anything else that we discussed so far? Anything else? Anyone with me?
All good.
Okay, thank you. So I'm going to share my screen again and move on. I want to go to page, go to page 20. Okay. So in page, on the next section, which is R.2, so that's all I had to say about R.1. So moving on to R.2, so that's my page 2. In R.2, we are looking at functions and models. And we already talked about a big topic, which is piecewise defined functions. But now I'd like to look at just a few questions for you to identify functions. Anyone remembers what a function is? It's okay if you say no, and I will remind you about it. What is a function? So let's look at these problems 1, 2, 3, and 4. Is the first one a function? It's okay if you're wrong. Is the first one a function?
Yes.
Yes. For each x value, there is only one y value. It corresponds to each x value, it corresponds only one y value. 5 corresponds only to 3. -3 only to 3. 7 only to 7. -7 only to 7. What about 2? Is this a function?
Yes.
Yes. 5 corresponds only to 4. 7 only to 8. 9 only to 4. Excellent. What about 3?
Yes.
Yes. -5 corresponds only to 1. 5, and so on and so forth. What about 4?
No.
No, because it's sufficient to show that for one value of x, that's sufficient. One value of y of x corresponds to 2 values of y. That is not a function. Good. That is a relation. Does it exist? Yes. But it's a relation, not a function. Now, the next step here that I would like to work on, I'm sure that everyone will know how to take this function and plug in 5.1, plug in this, and get these values. I don't think there is any problem. We just looked at an example with the accumulated value a few minutes ago. But what I would like to look at is something like this and what it means, because this is a crucial topic for calculus. Okay, so let's suppose I decide to go from Baltimore to New York. Let's say it takes, I'm very slow, let's say it takes 8 hours for me to go from Baltimore to New York. They're approximately 200 miles. And at some point in time, you'll ask me, let's say you call me and you will say, what is your average speed? And I'll say my average speed was the distance divided by 8 hours. That's my average speed. Let's say at some point in time I passed through Wilmington, Delaware. And at that moment, my phone rings and you ask me, what is your speed right this second? And I will look at the odometer and I will say 62 miles an hour. These two are completely different types of speeds. This one is over the entire time. I removed the times that I stopped to have lunch or breakfast or stretch my legs. So this was constant driving. Maybe it took me 10 hours or 9 hours, but this was constant driving. And this were 200 miles. So the average speed, can anyone divide for us 200 by 8 and tell us what you get? What was my average speed? 200 divided by 8.
25.
Very good. So 25. As I said, very slow. That was my average speed. Maybe certain pieces of the road I was driving 75. Maybe others it was congested and I was driving 10 miles an hour. But this was my average speed. It may have not been 25 miles an hour at all. Maybe it was only 75 and 10, 75 and 10, but the average speed is 25. This is what it's called the instantaneous speed. Is 62 miles per hour. At that particular instant, when you called me, I looked down at the odometer and I said, right now, my speed is 62 miles an hour. Okay. So here is the idea. Let's suppose this is the graph of the distance function. I'm going to say f of x. And from Baltimore to New York, this number is given by the slope of this line. Slope equals m, I'm going to say bn, Baltimore, New York. So bn, the slope of bn is 25 miles an hour. That's the slope. The slope of this secant line has nothing to do with trigonometry. It's the line that crosses the graph in 2 points or more, but 2 points in this case. Secant line. Okay? The slope of this line is 25 miles an hour. That's the average speed. Average speed. Okay. So then what is the 62 miles an hour? Okay, so 62 miles an hour, somewhere, let's say here it's Wilmington, and that speed is nothing else but the slope of this line, which is the slope of the tangent line at W. This is the 62 miles per hour. My graph is deceiving a little bit. They should not be parallel. There's two lines. So this should be steeper and this should be much smoother. So this is the average speed, which means nothing else but the slope of the secant line. And this, the 62 miles an hour, is nothing else but the slope of the tangent line at this point. Keep this in mind because this is half of the course, basically, this understanding this concept. Okay, so now I want us to pick a function. So I'm going to go back to, where are you guys? I'm losing you here. Okay, so I want us to use a function.